Good morning, good afternoon, everyone. This is Miss Mate, and my guest today is Miss Slavnika. We will be talking today about the meaning of the point of intersection of two lines. And in order to do that, we will be looking at a game, a cat trying to catch a mouse. Miss Slavnika, can you please explain for me this game?
Well, as you can see on the bottom of the screen, you have a cat and a mouse. What will happen, we will simulate the situation that a mouse will be trying to run into the safety in a hole in a wall, and the cat will be trying to catch it. So let's see how that will play. And the mouse is being caught. So what we need to look at again is how this situation can be modeled mathematically in a graphical form. And what you can see two lines being graphed on a grid.
Before that, Miss Slavnika, I can see here some numbers, 3, 4, 5. Can you explain these numbers for me?
Well, as you can see, the beginning setup, the mouse is at the origin. That's what we call 0, 0 position. And the cat is at the origin, mouse is at the distance of 3 meters in ahead of cat. So in a graph, 3 meters represents the y-intercept of a blue line. 4 for blue represent rate of change, which is a 4 feet per second. That is the speed of a mouse. And 5 represent rate of change of a cat, and that is a 5 feet per second.
Okay, so let's simulate again, and let's look at the graph this time. What does this point of intersection, the green point on the graph, what does it represent in terms of the real life situation?
Well, as you were watching the play, you had 2 points running along the red and blue line, and the green point represents these 2 points merging together in the same location. That means that the mouse is being caught by a cat, and that also means that both objects, mouse and a cat, are at the same position.
And at the same time.
At the same time. So let's look at the table of values. And you see that at the time of 3 seconds,
right,
the distance of for a mouse is 15 feet, and the distance for a cat is also 15 feet. And as you can see from a graphical representation, it is a point of intersection of the 2 lines, and that means that we are dealing with 2 points that are on top of each other, that have identical coordinates, and that means that the point of intersection of 2 lines intersecting are actually 2 common points.
Okay. I am wondering what happens if the speed of the mouse and the cat are the same. What does it happen? So I make sure they are both the same 5 feet per second. What can you tell me? Let's simulate and let's see what happens.
So if you look at the simulation, the mouse is safely in a hole. When you look at the graph, these 2 lines are running parallel to each other, and there is no common point. That means the cat will never catch the mouse, and therefore there is no point of intersection.
Okay, so having said that, you are telling me that I can have situations like this where the cat catches the mouse, or I can have situations like this where the 2 lines are parallel, the cat will never catch the mouse. Am I correct?
That's right.
Okay, so now mathematically, let's understand what that means.
Well, looking at 2 lines that not necessarily have to represent the motion of 2 running objects, we do have a common point. These two lines are intersecting at the location of 4 and 5.
4 and 5 right here.
So the point of intersection of these two lines, you can read from a graph, is 4 and 5.
Okay. Now, do we have other situations? We saw together the situation where we have one point of intersection. Are there any other situations? I believe we already saw some where given by two equations like this, for example, 2x minus 4, 2x plus 3, their graphs are given there. How many points of intersection do we have in this case?
We don't have any point of intersection. Lines are parallel. There is no common point. The slope of a first line is 2. Slope of a second line is also 2. They have a different y-intercept. These two lines will never intersect.
Okay. Now, any other possibility? Let's look together at these two. Let's look together at these two graphs. These are a little bit harder to graph. We graph them for you, and look what happens.
Well, we ended up with the one single line, but in fact, what we have two lines that are on the top of each other, and they share all the points.
Can you explain to me algebraically, what do you mean the two lines are one on top of the other?
Well, if you look at the first equation is actually the second equation divided by 2. Or you can look at it the other way around. If you look at the second equation, the first equation is multiplied by 2.
Oh, you're right. I can see here 2 times 2 is 4, 3 times 2 is 6, 6 times 2 is 12. So basically we got the second equation from the first one multiplied by 2. Is that correct?
Yes,
So
it is correct.
we have equivalent equations here. How many points of intersection do we have?
We have infinite points of intersection in this case. It is